Assalamualaikum and good day to Dr. Farid. My name is Muhammad Haikal bin Muhammad Ismail. Together with my group members, Ahmad Fahrin bin Muhammad Zaid, Adam Ikwan bin Muhammad Zahiri, Muhammad Hafizi bin Azharuddin. And we are from Group 2. We selected motorcycle shock absorber as our product. And in this video, we'll be explain about four main components which are threaded body, base, spring and nut. So the first part is threaded body, which is the main structural component of the motorcycle shock absorber. Its function is to support the spring and provide threads for the adjustment. For the material selection, we choose IC4140 alloy steel because it offers high strength, excellent fatigue resistance, and good machinability. After comparing several manufacturing methods, we selected CNC turning followed by thread loading because this process provides high dimensional accuracy and produce stronger threads. Moreover, to ensure manufacturing accuracy, GDNT is applied using straightness, perpendicularity, position, and circular runout. And finally, the main machine used are bandsaw machine, CNC machine, thread rolling machine, and deburring machine.
The next component is coil spring. So the material that we selected for coil spring is SAE 9254 silicon chromium spring steel. We selected this material because it has high elasticity, fatigue resistance, tensile strength, toughness and durability. So the manufacturing stages to produce coil spring, first of all is wire drawing, followed by coiling, then heat treatment, and then end grinding, followed by surface coat working, and lastly coating. The function of coil spring in the shock absorber is to absorb the shock caused by uneven road or terrain. This is to support the motorcycle and rider. Actually, it gives a rider more comfortable when riding the motorcycle. It keeps the tire in contact with the road by returning to its original form after being compressed. That's all for the coil spring.
So for material selection, we have compared 5 materials and we have selected carbon steel with zinc plating. So it has enough strength and wear resistance for repeated adjustment, and the zinc coating adds corrosion protection at low cost. So for the process, manufacturing uses cold forging plus thread rolling. Steel wire is cut into blanks, forged into the hex shape, pierced and internally threaded, heat treated for strength and zinc coated. So we choose this over machining because it is much faster, stronger and more economical. So for GDNT part, the key tolerance include flatness on the seating face, perpendicularity to the thread axis, and position tolerance on the hole, ensuring the nut tightens squarely and resists loosening.
So the last part is base. Material that we are selected is AISI 1020 mil steel. It is because it has high strength, good machinability, toughness and cost effective. So there are for the method production, actually there are several methods, but I will choose close die forging because it produces high strength and good grain flow. For the manufacturing stages, there are a lot of stages. We start with the material preparation, next the heating, followed by forming, flash removal. The next one is surface cleaning, finishing, hole making, strength improvement, surface protection, and the second last is assembly, and the lastly is inspection. So it is also have application of GDNT. For the first one is flatness, second one is perpendicularity, next is position, parallelism, and the last one is profile of surface. And I think that's all for base component. Thank you so much.